Hello, my name's Keith and this is lesson 3 of my Z80 multi-platform assembly tutorials. Now if you missed lesson 1 and 2, please don't worry because I'm going to be explaining things in a great amount of detail. That said, please go back and look at the tutorials later because there's a lot of good information there. Now these video lessons also have a text-based companion. Please go to my website and have a look at it because it will explain the same subject matter in some more detail hopefully, and you can go through it at your leisure at home. Now, today we're going to be looking at WinApe again, the Amstrad CPC. I will be going over some stuff on the other systems as well later, but at this point I'm just explaining the basic commands of assembly language, so it's easier and quicker for me to just explain them on the Amstrad CPC. So please bear with me on that if you're interested in the other systems. Now, let's have a look at what we're going to learn today because it's a little bit more complex than the last lesson, so I'm going to show it actually running before we program it. So, go to my WinApe here and I'll type run. And so we've got a basic program here, and the basic program is going to do part of the work for us and the assembly program is going to do the other part, and we're going to learn how to make both today. So if you've never used the Amstrad CPC Basic before, don't worry because I'll explain everything. So the program we've got is a very simple calculator. So all we do is we put in two values. For example, I can put in 15 and then I can put in 5 and then we can select a command. So if I want to subtract 5 from 15, I just press 1 for sub, and the answer it gives me is 10. And I'll just do that again. So if I put the first value as 2 and the second value is 5 and then I select multiply, you'll see we get 10. Now I'm using 8-bit commands here, so the maximum limit is 255, and this calculator can't do negative numbers. So there's some quite serious limitations on it, but as an early start on how to do these kind of commands, I think it's going to be a good example. So that's the basics of what we're going to create over. So let's just reset my emulator here and let's actually start writing it. So we'll bring in my emulator window here, my assembler window, sorry, and we'll start writing the program. And I'm going to explain line by line what we're going to do. So the first thing is our program is going to start at hexadecimal address 8000. So we need to type org and 8000. And then next we need to load in some variables. So we're going to load in A, which is our accumulator, and we're going to load that in from address and 9000 like this. I'll just move that in for clarity. And then we're going to load BC from and 9001. Sorry, just talking and typing, hard work there. So let me just explain here. So A is going to be our command, and we're going to load this from address 9000 in hexadecimal. So what we're going to do is we're going to get BASIC to actually put the values. A is the command, so whether we want to add, multiply, etc. So we're going to put that into the address 9000, and then BC are our two variables, var1 and var2. And you see I've specified 9001, but because BC is a 16-bit register, it's going to actually load from 9001 and 9002. Now, there's a slightly tricky thing about the Z80. It loads the values backwards. So the B value will actually load from 9002, and the C value will load from 9001, even though the C value is the smaller of the two parts. So if you loaded 10,000, for example, the 10 would be in B in 9002, and the 00, the second part, would be in C in 9001. It's backwards, a little bit strange, but you just have to get used to it. So anyway, let's carry on. Now what we're going to do next is we're going to look at our A value, and we're going to go the equivalent of a case statement. So we're going to end up with 4 commands, but we're going to start with just 2, just to get the program started nice and quickly, and just to give you something to see. So what we're going to do is we're going to do different jumps depending on the value of A. And the first one we're going to do is CP0. If the user has specified a 0, we're going to do a jump, and I'm going to use GAR, which can only do small jumps, but that won't matter in this case. And we're going to jump to a command called math add, which we'll write in just a second. And then we're going to do CP1 and JR Z math sub. Now, I'll just explain a few things here. As I said, JR is it's what's known as a relative jump. It can only jump 128 bytes away. It saves a little bit of memory. So generally, if you can use it, use it. If you get a command saying, if you get an error saying the jump's out of range, you're too far away, so you have to change it to a JP, which takes an extra byte. But we're going to use JR because that will just be just fine for today. Now, the when you're doing a comparison, the Z means that the difference is 0. So we're comparing to 1, so if A equals 1, the difference is between 1 and A is 0, so the jump will occur, otherwise it won't. Now, if we've got to this point here where the cursor is now, then none of the commands match what the user gave us. So maybe the user gave us a 5 or a 66, who knows. So all we're going to do is we're going to load A with 0, and we're going to now create a label called save result. And this is where we're going to come back to when our other commands that we've not written yet have been run. And what we're going to do is we're going to do a load and 9003. If you remember, I said 9002 is being used by that B value that we have before. So I'm using a different destination and source just to make everything nice and clear. And what we're going to do there is we're just going to load A into that memory address there. Let's put these nice and neat, so sorry about that. And then we're going to return, which goes back to basic. So we've got the start of our program here. This will handle the input of the command, but we need to create some other functions here, don't we? So let's create math sub. And the way we're going to do this is we're going to load A, C. If you remember, I said that B and C are backwards in memory. So C is actually the first of the two variables. And then what we're going to do next is we're going to do sub B. Sub is, of course, subtract. So we've loaded C, the register C into our register A, and then we subtract B. And then all we're going to do next is we're going to jump to save result. So our result is in A. We jump to save result, and save result will save it into our memory address that we want it to for basic. So that's our first command. And the next one is just math add, which is very, very similar. No problems here. Load A, C, add B, JR save result. Very good. So let's do a assemble here and check that works. Sorry, my window's out of frame there. We'll just get that in. No errors. Very good. That's what we hope to see. So now we need to create a little basic program. So just bear with me a moment and I'll get my reference notes up here. And so first thing we want to do is clear the screen. And then what we want to do is an input command. So we're going to, the first part of an input command is a text string that we show the user. And then I'm going to put a semicolon. And the second thing is the variable we're going to store the user's response into. So this makes the computer say, hey, val1, the user gives us a number, and we store that number in A, which is just a general variable I'm creating. So on 20, we want to do input val2, semicolon B. And then finally, we want to do 30, input 0 equals add, or 1 equals sub. Now you'll notice I'm being fairly dumb here, if you will. I'm just using a number to specify the commands. We could be clever and we could process the ASCII codes of minus and star symbols. Perfectly possible, but we're not going to do it. We're just going to stick to numbers now to make it nice and clear. Now, the next bit is possibly the more interesting bit if you're not familiar with BASIC and machine code. So we're going to use a command called poke, which is nothing about annoying the computer. What this does is it puts a byte of data into a memory location. Now, maybe I shouldn't have used A, B and C here. You've got to bear in mind the A, B and C in BASIC here are not the same A, B and C in my assembly language here, so that's a bit misleading. I apologize for that. But what is definitely the same is this and 9000 in the poke command is the same 9000 command here. And this poke command is very similar to this command here. It's putting the value of C into that memory address. And the read command, the matching read command, is kind of the bridge between BASIC and assembly language. So our poke command is going to put, all you need to remember is our poke command is going to put the value into the memory address, and the poke command exists on the MSX and the Spectrum in very similar ways. So this is a really good way if you want to do things between BASIC and assembly. So let's carry on, and we're going to do another poke command. I've changed case there, but that doesn't matter because BASIC is not case sensitive. Now, as you've noticed, the two variables are being written in two separate poke commands, but they're being read in one LD command over here. Because this is 9001 and 9002 being read in. The poke command can only work with 1 byte at a time, so that's why there's that difference there. And then 70 is going to be my call command, which is going to start the assembly language program. So I'm calling the address I specified here. And then the last command is going to be 80, and this is going to be print peak and 9003. I have to apologise for my typing. It's quite cold in Japan at the moment, so my fingers are a little bit numb. Bear with me here. So the peak command is the opposite of poke. Poke puts data into memory, peak pulls it back out. So we're pulling the byte out from 9003, and of course that's what our save results save to. So this is a great example for how to make BASIC work with assembly. You're passing values to assembly via temporary memory locations, and you've got that call command making assembly do all the work. So let's see if I've made any mistakes. So if we do a run, we put the first value as 3, the second value as 4. Oh dear, I've made a mistake. Yep, I've put a colon there. That should have been a semicolon. Let's try again. 3, 4, and let's add. That's 7. That sounds about right. Let's try it again. 4, 3, 1. Now, I did the other way around because this can't do negative numbers the way we've coded it. So you can try it. Let's have a look at what happens. Might be quite interesting. 3, 4, subtract 255. If you're wondering why that happened, please have a look at my other video tutorial explaining negative numbers and hexadecimal, because if you've seen that, it will make a lot of sense. We will be looking at this much later, and we will be making it more advanced so it can do numbers above 255 and negative numbers. But at the moment, we're just going to stick with the 8-bit mathematics, which limits us to 0 to 255. So anyway, we've got our little program here. Let's have a look at some interesting things that I think you might need to know later. So you'll see here we've got a command CP0. Now this compares the accumulator A to 0, but this command here takes 2 bytes, and there's another exactly the same command we can do which only takes 1. So we'll put in OR A here. That does the exact same thing. It looks odd, doesn't quite make as much sense to read, but it saves us 1 byte and it's faster. So always try and use that if you can. And then there's another one here. This loading 0 into A, there's another command we can do here, which is XOR A. Now I haven't explained XOR yet, but it's a command that flips the bits of a register. Now if you with A, sorry. But if you flip A with A, you're always going to end up with 0. The trick is load A, 0 takes 2 bytes. XOR A takes 1 byte. 1 byte is faster. So never use LD A, 0 unless you've got some very special reason. I'll explain one in a later lesson. But at this stage, if you want to save memory, if you want the fastest code you can, always use XOR A. It's always faster. So those are a few little tricks there. I'm going to continue use it for clarity using the normal, the CP0 and the load A, 0. They're also in the source code because I want to make it easy for you to read. But if you want to make the fastest code you can, that's something you want to do. Another interesting thing to note here, we've got this sub B command, but there is also a negative command which flips a positive number into a negative one. So we could have done this as load A, B, and then neg, which would flip A into a negative number, and then we could have done add C. And we'll just try compiling that, and we'll have a look and check that's true. There we go. So depending on the case, you may have a case where you need to invert a number and that convert it to positive to negative, sorry, and that's a good way of doing it if you need to. So it's a command to bear in mind as well. It's actually, of course, slower in this case because we've converted 2 commands into 3, but I did just want to explain that command now that we're not looking at addition and subtraction, because it's an important thing to know about with subtraction. So let's carry on. We want to add some more commands to our little program here. So we're going to go back up to here, and we're going to put some more CP commands in, CP2. So this is our math multiply command. And then CP3. Yeah, assembly isn't case sensitive on WinApe, so just please ignore my somewhat random use of case here. And this is math div. Is that all right? That was correct, yes. So what we need to do now is we need to create oh, I forgot to leave. Should have put a colon there. It will let me get away with that, but not very clean, so we don't want to do that. So now things are going to get a little interesting. So we want to do some multiplication here. Fairly simple, you probably think. How do we do that in Z80? Well, the Z80 can't do multiplication. And it can't do division either, which you probably think is a bit crazy. What on earth's going on? This is a processor. That's one of its main roles, surely. But it's a very simple processor, and it's actually not got a command to do that. But you've got to bear in mind the Z80 is very, very fast when you're working within assembly. So we can actually do the work for it, and it's still going to be really quick. Remember, BASIC is all working in assembly at the end. So anything a BASIC can do, we can do in assembly. We might just have to think a little bit and work out how to make it happen. So let's carry on. So how do we do multiplication when we've got no multiplication? Well, we add the value to something several times. And by adding, for example, if you're multiplying some 5 by 2, you add 5 plus 5, and that's the same thing. Times 3, 5 plus 5 plus 5. No problem. So that's what we're going to do here. So what we're going to do is we're going to load A comma B, and then we're going to CP0. And if we've been told to multiply something by 0, there's no work to do, so we're just going to give up. So we'll just do a JRZ, comma save result, and then next we're going to do load A comma 0, and now we're going to do math mult again. So as I said, we're going to need to do a loop because we're going to add the value to it. We're going to add a value over and over again. So what we need to do is we need to have a loop so that we can jump back here for the next addition. So we're going to do add C, and then we're going to do DJNZ math mult again. Let's have a look at what. Oh, and then finally we want to do JR save result. So let's have a look at what that actually does. So as I said, we've got B, which is the number of times we're going to do our multiply. If it's 0, we're not going to do anything. The answer is just going to be 0. So we just fly back to save result. And we know A is 0 because we've just compared it to 0, so we don't need to do any more. Now, if we get here, A isn't 0. We're going to use A to remember our result of what the multiplication was. So we started off at 0. As I said before, we could have used an XOR A here, but I'm not going to for clarity. And then here we've got an add C command. So we're going to add C to A. And then DJNZ is a special kind of jump. It means decrease and jump if not 0. And it always works with B. It can't work with any other register than B. So it's going to decrease B. Is B 0 yet? No, it's not. Do it again. Is B 0 yet? No, it's not. Do it again. And the reason we had to do our CP here is because it does the comparison after it's decreased B, and if it decreases B when B is 0, it will end up as 255. We did have a discussion of that last time when we did our clear screen effect, but as I say, that's just why I'm comparing to B before this loop. I should point out I'm not trying to claim these are the best multiplication division routines. They're simple, quick. I didn't make any real attempt to make them fast. They'll certainly work if you need one, but please try and make something faster or have a look around for something that's more efficient, because I'm sure there is something. But anyway, so we're going to repeatedly add C until B equals 0, and that's our multiply command. So now we need a division command, and let's see what we can do here. So our sort of logical routine for division is very similar. We load our value that we want to apply the division to, and then we subtract the other value from it, and we count how many times we were able to subtract from it before we got to 0, and that will tell us our how many times the smaller number is in the larger number, so to speak. So let's make a start on that. Math div. And so what we're going to do is we're going to do LD A comma C, and then we're going to do CP0, and then we're going to do JR Z comma save result. Now, of course, division by 0 should be infinity, but for the purposes of our program, we're not going to fire out an error. We're going to say something divided by 0 is 0. So slightly odd mathematics there, but never mind. So now we're going to load D comma 0. D is going to be our counter for how many times the value was in the other value. And then we're going to do math div again. And we're going to do sub B. I'll go into these in a second. Inc D. JPNC. Oh, let's use a JR. That's more sensible. Math div again. I will explain this in a moment. Just please bear with me while I finish typing these commands. Tech D. And then we just want another JR save result. So let's copy paste that. Save my cold fingers. Okay. So what have we got here? So our first value is in A, and then the subcommand always affects the accumulator. So we're subtracting B from A, and then we're increasing our counter because we are increasing every time we subtract B. And then we say this command says, hey, when you did that subtraction from the accumulator, did you go below 0? The C is the carry, and when you go below 0, the carry will flip over. Will flip. So NC means no carry. So if there was no carry, keep subtracting. We're okay still. If there was a carry, you've gone below 0. And so what we have to do is, because we've just increased D, when it does flip over, D will be too high by 1. So we need to decrease D by 1 so that we've got the number of successful subtractions in A, and then we jump to our result. Brilliant. Hopefully, if I've done my coding right, this will work. So we'll just do an assemble here. No errors. Good start. And then we want to do edit and 30. I'll just show you just a little bit more in case you're not familiar with BASIC. We can do a list so we can see our lines, and we can do edit 30. And then I want to do comma 2 equals mult, comma 3 equals div. There we go. Let's run our command now. So if we want to do 4 times 3 and mult, we get 12. Well, what happens if we want to do 99 divided by 9? Let's try that. 11. And there we go. I think we have a working program here. So, okay. Well, I think that covers everything. Hopefully you found this interesting. I'm hoping you understood the intricacies there of the multiplication division formulas. You're probably despairing a little bit, thinking, well, hey, why doesn't Z80 have these commands? But really, don't worry about it, because even though assembly is very crude and you have to write everything yourself, you can just drop in the modules to do what you need and just call them whenever you need to do the work. So the thing you're coding today and you're thinking, oh, this is going to take me forever, the multiply routine, the sprite routine, the file routine, whatever you need, once you've got it working, it's just as easy to use as anything would be in C++ or C# or BASIC, whatever you're used to. So you have to start with the building blocks, but you can build these huge structures and just use them as just like anything else. And the beauty of assembly is you've always got total control, and you know you're getting absolutely every ounce of speed out of the system because you are programming as low as you can get. Now, I should say with multiplication and division, there is another trick you can do. If you just need to double or halve numbers, you can use bit shifts to do that. We will be covering them later, but at this stage, I think we've covered enough for today. So please try out this program. Definitely check out the website because all of this is documented on there. I hope you enjoy it. And if you've liked this video, please like it, write comments, whatever you want. Thanks a lot for watching. Bye now.